So guys, today we are going to study about magnitude distortion. Okay. So what is the meaning of a magnitude distortion? If system provides unequal amount of amplification to different frequency. Okay, if system provides unequal amount of amplification, okay, amplification to different frequency components of input signal, then system is having magnitude distortion. Then system is having magnitude distortion. Okay, so what is the meaning of the magnitude distortion? If system provides unequal amount of amplification to different frequency components of an input signal, then the signal will have a magnitude distortion. So you are giving a different frequency input like x1 of some frequency, different. So x1 of t, it's having a two kinds of a frequency, like suppose sine omega t plus sine omega 2t. Okay, and it's you are providing this to one LTI system. So what you will get, a different amplifications you will get for this signal, a1 sine omega 1t plus a different amplification you will get, a2 sine omega 2t. So these a1, these a2 is what? These are this a1. If a1 is not equal to a2, okay, so magnitude distortions will happen. So a1 is not equal to a2, then we can say magnitude distortion. Okay, so suppose if you have a a1 here, means a1 dash here and a2 dash here. If you are getting some amplifications here, if these amplifications are same, means if your whatever the a1, whatever the value is this, but if this and these values are same, then we cannot say that distortions happen. If these values are different, then only we will say the distortion happen. Okay, for example, like you can take one particular example. So in example, h of s is given as 1 upon s plus 1. Okay, so s is equals to j omega. So h of omega is equals to 1 divided by j omega plus 1. Okay, so what is the magnitude of h of omega? What is the magnitude of h of omega? 1 by root under 1 plus omega whole square. Okay, 1 plus omega whole square. This is omega, and the distortion is like, means you are getting response like this. Okay, yeah. When the omega value is 1, you are getting 1 by root 2. When the omega value is 2, you are getting 1 by root 5. Okay, so this is one example. H of s is equals to 1 by s plus 1, s is equals to j omega, magnitude will be 1 by root under 1 plus omega square. So all this magnitude is depending upon the frequency. So when frequency is 1, you are getting 1 by root 2. When frequency is 2, you are getting 1 by root 5. Means at a different frequency you are getting the different value. So that is the meaning of a distortion only. Okay, so if you want to write in the form of a LTI, means LTI system, see, this is your LTI system. You are giving sine t, and you are giving the different input sine 2t. So what magnitude you are getting at omega, this is one frequency, 1 by root 2 magnitude you are getting. And what magnitude you are getting here? You are getting 1 by root 5 magnitude. Okay, the same thing will be written here, sine t, but you have to write some angle phi 1. Same thing, sine 2t, but with angle phi 2. Okay, so different magnitude. So these and these values are different. So these values are different, so different magnitude multiplier for. Okay, so so this making a distortion. Okay, yeah. And what was the transfer function? Transfer function was h of s is equals to 1 divided by j omega plus 1. Okay, now you need to find the value of a phi 1. So phi 1 means at omega 1. So you are writing 1 plus j. So what will be the angle? Angle, you need to find the angle. Angle will be minus tan inverse this. This will go upside. So minus tan inverse 1 by. So minus tan inverse 1 by 1 is coming. So 45 degree. Minus 45 degree. So here phi 1 is value is minus 45 degree. And for 2t, so this will be 1 divided by 1 plus 2j. Okay, so this will be angle minus tan inverse 2 by 1. Okay, so whatever the angle, calculate it and substitute it here. So like that way we are calculating. So what is the meaning of a distortion? Distortion. So distortions are beneficial in some application like filtering. Okay, so distortions are beneficial in some application like filtering. Okay, so distortion are a disadvantage or unwanted for application of a speech signal. You can say we don't need distortion. Distortion are disadvantages or unwanted for application of speech signal. Example, mobile communication. Okay, what is the meaning of a delay or phase distortion? What is the meaning of this delay and phase distortion? So if a system provides unequal amount of a time delay to a different frequency, write it down. If system provides unequal amount of time delays to different frequency components of input signal, then system is having distortion. So if system provides unequal amount of time delay, what is the meaning of this? Unequal amount of time delay to different frequency component. So see, uh, you have a LTI system. LTI system. You are providing x of t. The value is sine omega 1t plus c, suppose sine omega 2t, and this is y of t is equals to sine omega 1 t minus t1 plus sine omega 2 t minus t2. So this phase distortion is coming. Okay, see, omega 1 2 signal, omega 1 t minus t1, some distortion came. Omega 2 input was there, but output we are getting some kind of a distortion. So this is known as, and here one thing is that your t1 should not be equal to t2. Okay, so if t1 is not equal to t2 only, then only the distortion, delay distortion will come. And we have a distortionless LTI system. What is the meaning of a distortionless LTI system? Write down the next topic. Distortionless LTI system. What is the meaning of a distortionless LTI system? You have y of t, k, x of t minus t naught. Okay, now if you will do the Laplace transform of this, so y of s is equals to k x of s e power minus st naught will come, because time delay is there. Okay, so put s is equals to j omega. So if you will substitute, and y of s by x of s will come, h of s is equals to k e power minus st naught, y of s by x of s. So k e power minus st naught, and when you will put s is equals to j omega, so h of omega you are getting k e power minus j omega naught t naught. What is the meaning of this? You are getting, means the magnitude of this only k will come. So h of omega magnitude is only k you are getting. What about the angle? So magnitude of h of omega is k only. Okay, because this magnitude of this is 0, and angle is this part. Angle of h of omega is nothing but minus omega naught t naught, except j, whatever the things present, it will be angle only. Okay, so we are getting a negative angle, so negative angle will be in this only. So this is positive, this is negative, so it will give you a negative angle, positive, negative, so negative value is coming. Yeah. So what is the meaning? Write it down. For distortion less LTI system, magnitude characteristic should be constant, and phase characteristics should be linear. Okay, so this is omega value, this is angle h of omega, minus omega t naught value, this is 1 minus t naught 2, we are getting minus 2 t naught 3 minus 3 t naught, means angle it's so it depends upon the frequency, so it's like a linear only. See, we are getting the linear. So at minus t naught we are getting 1, at 2, so this is minus 2 t naught, it's like that. At 3 minus 3 t naught. Okay, so no phase distortion, no phase distortion, because linear graph. Because linear graph we are getting. So if phase characteristics of a linear, if phase characteristics are linear, then the system will not have a phase distortion. If phase characteristics are linear, then the system will not have phase distortion. So note this point. If phase characteristics are linear, if phase characteristics are linear, then the system will not have phase distortions. Okay, so this was the topic regarding the magnitude distortions, phase distortions. Now we are moving for a Fourier series analysis. Okay, Fourier series analysis. So yeah, in in a Fourier series we will check the Fourier series analysis. So there is a lots of topic in a Fourier series. Okay, so Fourier series will continue tomorrow only. Okay, so we had completed a lots of part, so we are moving to a next, means a main part of the signal system, Fourier series, Laplace transform, then jet transform, all the main domains came. Okay, so we'll start this topic tomorrow, Fourier series.